filtration and pressure tank cellar. Outside of the wet area, the mixing container for the diatomite dosage is situated on the cartridge filter. The diatomite is mixed with water and made ready to add. Because the diamite is very abrasive, the mixture is measured with a Promac W. A very old EMF type speed mark is installed in the equipment, which has withstood a long operating period without problem. The level in the tanks is measured hydrostatically. In order to prevent running empty and therefore to prevent pulling in gas, liquefying FTL50Hs are installed. The filtration area consists of three main devices. First, a PVPP filter with which the proteins is filtered out. Second, a diatomite filter, which is mainly used to take out the yeast cells. And third, sterile polishing filter, which is implemented here as a trap filter with which the beer is filtered to clarity. The operation of the cartridge filter is shown in the animation. In some breweries, the largest amount of particles are removed with a centrifuge in order to keep the use of diatomite as low as possible. The centrifuges are also provided when, instead of the diatomite, a membrane or cross-flow system is used. The cartridge filter, presented here, is therefore designed to also deal with large particle loads. The diatomite is therefore used in order to increase the filtration surface and to constantly renew it. In the carbonization unit, a Huffman's CO2 analyzer sets and determines the final CO2 contents of the beer. A vortex flow sensor is installed at the gas inlet. The next shot shows PVPP filtration with flow and pressure sensing systems in the filtration cycle. Targeted proteins can be filtered out of the beer with a PVPP, which would otherwise cause cloudiness in the beer later on. Temperature is key to protein stabilization. The colder the beer, the easier it is to remove the protein. In addition to hydrostatic level measurement, also capacitive instruments such as a LiquiCap are used, especially in the dosage vessel, which, due to its very small volume, requires very fast regulatory reaction. The PVPP filter, as well as the diatomite filter, operates according to the cartridge filtration principle. An advantage of cartridge filtration is that fully automated work is possible, and no additional wearing parts are involved other than the seals. There is upstream metering of the diatomite being dosed in the diatomite cartridge filter outlet. The filter is, as with nearly all containers, secured with a liquefying against running empty. If in this production area the beer comes into contact with oxygen, it must be brought back into the fermentation cellar at great efforts. The most important parameters are, as with every filtration, the pressure differentials between the in and outlet. The main stream is measured by the Promac H, as well as the dosage volume. The Promac H, with a small nominal size, provides the necessary signal here for the dosage. We see the start of the filter with the diatomite dosage and switching from water to beer. The pre-coat is not shown here. A first layer of very coarse diatomite is washed out with water on the cartridge. After the filter inlet, we see the filter outlet. As the filtered, clear beer comes out of the filter. With the start of beer filtration, the container is cooled to the filtration temperature of -2 to +5 degrees Celsius. One can very easily see the condensation on the filtration tank. The dosage vessel of diatomite has both a level measurement with the Delta Pilot FMB50, as well as a liquefying for empty notification and multi-cup overfill protection. In order to disinfect and polish, a standard sheet filter is used here. This is a classic method to remove microorganisms and final particulate matter. The sheet filter is being replaced more and more by membrane and cartridge filters. This shot shows the rinsing of the filters and the flushing of water before the actual start of filtration. It is also very important in this area not to have any oxygen enter into the beer. The complete filtration assembly must be completely filled with water and rinsed so that no more gas bubbles are seen. The water is pushed out with the beer. In the phase separation of water beer, there is a lot of potential to prevent product loss and to reduce wastewater volumes. The sheet filter has no additional measurement devices other than pressure control for the inlet and outlet. The pressure control is very important in order to establish when the filter must be cleaned or when the filter sheets must be exchanged. The layers consist of cellulose and ensure for a certain period of time a very large surface area. Then they start to close up and thicken, so that it becomes necessary to replace them. The tanks in the bright beer cellar are designed with a round dished bottom. The beer is stored here between filtration and filling. The area must be handled with a very hygienic manner, because there is no additional handling between it and the filling. In order to assist in cleaning, there are very few internal